Hello, welcome to the quick tutorial on Docker. I'll try to be quick. So as you see in our repository, we have a bunch of things that are marked Docker, and including a Docker ignore file. Um, Essentially, if you've watched the quick intro on what Docker is, it is a small container, like a subcomputer in a computer, and then you can continue to have subcomputers inside subcomputers, but that's another story. So how do I build this sub Docker image, aka like the small computer? Well, let me explain this. This is the main file, which builds all of the Docker image. So, for example, if you look here, if you just go and do Docker build, it will start by copying, mounting, doing stuff like add, which mounts the code that is inside Soccerbot inside to the Docker build context, and it starts running through these tests. So, one, for example, if you can see, step 16 is OS's Ubuntu sets an environmental variable. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14. Yeah, basically like that. So there are two stages to the Docker build. Stage is basically you build one Docker image in this first stage, and then from this stage you copy information from the dependency. The reason why we have stages is it will speed up the builds. Like for example, if you're just building in one, you want to copy over the finished built artifacts so that the second image has a smaller size and builds faster. In this case, the dependency stage, all it does is it goes into the entire repo and looks for all the required dependencies and spits them out in a file inside root dependencies. And then in the builder stage, you can see that it takes from the dependencies. For example, in copy from dependencies, I'm copying from this image, previous image, into this builder image, and then running these installation steps. Quick overview of what each thing does. Like from basically tells you that I want to start from this certain image, and run is basically like a command line command. You can use any command that you can do on a Linux computer. Work to resets the work directory. It's not very complicated. There are only a few steps. Most of them are like run, basically. So think of it as a bash script that builds that is running inside this container and copying information from the base computer. Things to look out for. Yeah, so in general, the best practice for making these Docker images is to have the things that take a lot of time in the beginning. For example, over here in the beginning, I'm installing apt-fast, which is a tool that will allow you to install apt packages faster. Install a whole bunch of dependencies that is probably I won't change the list, and then the slow stuff like installing CUDA, installing the pip dependencies, requirements.txt, and then running the installing the ROS dependencies. And then I go on to the fast parts, which is like downloading an image, the latest image from the web. The stuff that will most likely change the most is on the bottom, and the stuff that is not changing the most is on the top. Like environmental variables, like these can change at any time. Yeah, so I just ran docker build. There's another Docker image inside an external. This one is just to build the Docker image of the simulation. Um, some things about what I'm doing here. For example, over here I have a if statement, so this only runs if I am building on the ARM architecture. Oh yeah, speaking of which, we have one Docker file for two different system architectures. Normally on your computer you have an architecture AMD 64. This is very common. Macs have mostly ARM architecture, so every time you have a different architecture you need to build the code differently so that it works for um, their compiler. Um, but basically the base image is from Utrobosaka Noodec. For example, you can just go to Docker Hub, and then you can find this our image with 603 posts. And basically to pull image, you can just go Docker pull image. It'll just pull the image. One thing about these layers, every single step in Docker is its own layer. So if you have, for example, completed 32 out of 36, and then you made some changes in the next step, then this is cached. So for example, I can just go here, copy, docker run it bash, and then I am now in a Docker image, which is exactly what the image looks like in the certain stage. This is very useful for debugging purposes. Um, so whenever you need to run like test like a certain intermediate step, you can just go here and then use this image stage, docker run it. Run is to there's two commands. Run is to start launch an image as a container. So this is a intermediate image stage. So you can do run. It dash it means go inside the container and like run and interactive basically. So for example, if I don't do it, it just finishes because it just runs the bash command and then it exits. But if I do it, I'm now inside the container. So one other thing, when I do it, now this container, this image is running, and the container ID is C3B. So for example, I can do docker ps-a, and then you can see that this top one, this image with a nickname pedantic hoover, is been running for 13 seconds. This is the one. This is the image ID, and this is the container. So understand the difference between the image and a container. I cannot do docker run for containers. For if I want to go inside that same container, I have to do docker exeic and then paste the container ID rather than the image ID. And now I'm in the same container as this one. So two bash commands are in the same container. If you ever need help with this, you can just go back here and check out the reference guide. It shows you how to exec and run. I forgot to add run. So yeah, most important thing is to know the difference between a container and an image. So now, for example, when I have left the container, you can see that I have a whole bunch of see, this one has been created 46 and so. If I do ps-a, okay, forgot to mention docker ps-a gives me the list of all the containers that I've run and have exited on my computer. For example, maybe 2 months ago I've been running some other container but it's been not dead. To do a cleanup, two ways you can do it. Docker remove $, Docker psaq. So what this does is means this I ran this Docker psaq, and then the output of Docker psaq is the list of only the container IDs. So basically, if I do docker remove, I clean up all of these containers I've been running, and then I can see that no more containers or containers have been cleaned up. So again, you can see this here. The thing is, each Docker image has a tag. So to see the image that I've just built, Docker image os. So this is a whole list of images. So for example, this image that I just built, Docker build ID dot, I can add a -t here to tag it a new image test. So now I took this layer and I tagged it with new image test latest. So for example, Docker image os. You can see that this is the image that I've been running. Again, I can just do docker run it bash to start an instance, and I'm now inside the image. What have I not covered? Yeah, so you can change the tag of an image. You can also push an image, so docker push and then the tag name. So this is automatically done on every pull request that goes into the master. So we have automatic action that will build the Docker image, the ARM version and a regular version, and send it to Docker Hub. So pushing and pulling, like Docker Hub is basically like a storage of all the Docker images and such. What else have I not gone through yet? Yeah, so in the next tutorial I will explain how to um, about Docker Compose. Thank you for listening to this tutorial.